Hello and welcome to Redona Designs. In this video, we're going to look at sheet metal design. And I'm going to show you the approach that I like in designing sheet metal parts, which is the top-down way of design. So mostly there are two main types of workflow, which is the top-down and bottom-up type of design. So in top-down design, you look at the design holistically with all its parts, and then later on you can save them as individual parts. And in bottom-up design, which is the one that is much more familiar with us, with many people rather, is where you design each and every component and then you bring them all up to make one single part. Let's say, for example, as a vehicle, you want to look at the vehicle as the whole thing and then break it down into its individual parts, the tires, the hood, the bonnet, and everything. Yeah. But now that is now the bottom-up approach. But in the that is the top-down approach. But in the bottom-up approach, you now design the tires to its completion, and then you design the body to its completion, which is the chassis. You design the seats, and then now you bring them all up into one design. That's now bottom-up. You start with the individual components and then build them up. Now, I prefer sheet metal. With sheet metal, I prefer the top-down. And in this video, we are going to address all that, and I'm going to show you my approach, the top-down approach that I use, and we're going to look at its cons and pros as we are going to deal with this part. So the part we're going to deal with today is a very simple part. It's an electronic enclosure, and we're going to use convert to sheet metal as a way of making this part. So let's start designing, and we're going to start from the front plane. Have a sketch, take the center rectangle. Let's just design it on the fly. So let's give it a length of 100 millimeters, and then the width, let's give it 60 millimeters. And then we're going to extrude it. Then we're going to extrude it in mid plane, and we're going to extrude it to say 150 millimeters. Okay. All right. I'll explain the reason why I've approached this in this design, especially in this manner. So we're going to go to the sheet metal tab and create sheet metal. So we're going to first start with the base of the part. So we're going to take this face, the bottom, and then click on that edge and the back edge. Thereafter, we're going to reverse the thickness side and make sure we have our keep body command, and we're going to make it using a thickness of 1 millimeter and a radius of 1 millimeter. After that, we click on OK, and with that, we're going to choose the same command again, click on the top face, but this time around we are going to click on the reverse thickness. Reason why is because we want it to be on top of this, of our earlier model, and in this one we really don't want to keep the body, so we're going to choose this bend edge and the one on the opposite end, which is this one, like so, and then we click on OK. Good. And you can see that our sheet metal part is beginning to take shape, so we can just tweak it a little bit so as to make it much more practical. Yeah, but this is actually a very good generic box. So to do that, we right click on that one on the base, and then we isolate it, and then we need to give it some flanges somewhere where we can screw it in place. the top and this base. So we're going to go to edge flange, and then we're going to make it, let's give it 12 millimeters length of our flanges. Then we're going to take this side, what's up, this one, this side, and this side. I'm having a problem with my mouse button. I think it's updating itself, but let's correct it right here. It's 12 millimeters. And then we're going to choose this other edge like so, and then click on OK. All right, so maybe let's edit these flanges first. And it really matters in sheet metal, it really matters how you bend your edges. So we want to choose the first option, the material inside. We want it to bend on the inside, because remember, we're having these flanges of the top part that are going to be on the side. So we really don't want them to overlap. So after that, we click on OK. And what I like to do, the reason why I started with the box, is I want now to mirror these flanges that we've just created onto the other side. So we're going to take the right plane, and this is also, I'll emphasize on, whenever you can, just use the primary planes, because when you draw from the primary planes, it helps you to down the line when it comes to features such as mirroring. So you don't have to create planes in order for you to mirror. So having said that, we choose this feature. It's going to translate to the other side. You click on OK, like so. And when we exit isolate, we can see that our body has really begun to take shape, and it's actually quite doable. So we need to see how to secure these two parts together, right? So we're going to click on that part, that face rather, click on OK, and we're going to change the display to hidden visible lines so that we can actually see our part right there. And what we want to do is to actually use some circles. The purpose of these circles is just basically, they will help us down the line. I want to use a hole wizard to create holes on this part. Actually, we didn't need the other part, because we have the part right here again, because we started from the primary planes and then we use it as the mid plane. So now we're sure that whatever is happening on the left side is going to be replicated on the right side when we mirror it. So select these three circles and then we make them equal, and then just save. We create the distance there to be, say, 35 millimeters. That's just an arbitrary figure. You can choose yours, should you, if you want. And then this one, we're going to make them, say, 100 millimeters. And that's good enough for now. So having done this, we can now do some further alignment of these holes. So the distance from the center point of the hole to there, let's make it 5 millimeters. And then same to this other one. The bottom, let's make it 5 millimeters. And the radius of the hole really doesn't matter, circle, but just give it 3 millimeters. Because later on we're going to use, okay, you can use a variety of things. You can decide to weld on a metal on the other side, or just use self-tapping screws. So let's say for 2 millimeters. Okay, no, not really. Let's give it, say, 5 millimeters, just like the other side. Good. Okay. There and there. Let's make this one's vertical, and we have fully defined our sketch. To do right here, click, remove that one, and then select everything, and then mirror to the other side. That's good. So with that, we can change the sketch color so that it becomes much more visible. You can change the sketch color, make it something like this, or this type of green, something that you can see through our normal shaded view of SolidWorks. So return to shaded view, and we go and choose our hole wizard. So within our hole wizard, we just choose the dowel holes, and let's say we want to make it using, we actually want to use the, what's it called, the self-tapping screws. So we're going to choose through all first of all, and on the outer shell we're going to use slots. So we're not going to use dowel holes, we're going to use slots. And the reason is because of sheet metal, after the bending, you can never really pinpoint, unless you're stamping the part on a mold or something, you can never really pinpoint where the hole is going to end or start. So there'll be a lot of misalignment after the bending. So, and especially the thicker the material, the more that you might find all those inconsistencies on several parts. One part might turn out okay, but the other one you might suffer from misalignment. So we accommodate for that using a slot. So we're just going to have a small slot, say 2 millimeters long, and I say 3 millimeters hole size here. And we go to position, and you click on this face. And with that, click on that one. And before we continue, we need to make this one vertical. Reason being is because this part is going to slide from the top. And then you go back to a point. And yes, actually you can do that. So when you're doing hole positioning, you just use the point. So whenever you feel like maybe you've clicked somewhere and you can't really get back to your holes, you just remember it's the point, yeah? So it's just a sketch and that's a point. So you click on that one. Make sure they are coincident with the center of the circles that we created in our previous sketch. They there. And there. Then we go back to our type here, and then because it's a through all, we only want it to affect the top body. So we only want it to affect the cover at the top, like so, and then we click on OK. So that's good. So you can see that the holes were translated up to this other side. So another thing to take note when you're designing sheet metal parts is that there's a specific distance between the, I can say the hole and the bend, the distance between the hole and the bend, the center of the bend. So you want it to be at least 1.5 times the thickness of the sheet metal. So in our case, it is 1 millimeter. So you want it to be at least 1.5 millimeters away from the bend, because when it's too close to the bend, the hole is going to distort, because this part is going to be manufactured when it's flat. So when you have it too close to the bend, it's going to distort in some way, shape, or form. So you want it at least 1.5 times the thickness of the metal away from the bend, at least 1.5 times the thickness of the metal. So with that, all that's left to do is now to create the bends. You can see it's the holes onto the main part, which is the base, and the base, that needs to be a hole, it doesn't need to be a slot. So you go back to the hole wizard, you select the dowel hole. We're going to select a dowel hole of let's say 2 millimeters or 2.5. Let's put 2.5 because after powder coating or painting, it's going to reduce that hole quite a bit. So that's that, and we can choose either side. I'm going to choose this side to start off, and then just like in the other sketch, just follow through. So that's the reason why we chose this sketch to be this color. Change the color so that we can see it through and through and through. So yeah, and click on OK. You can choose the feature scope, but because you already have these slots, I don't think it's going to be affecting it. But just in case, it's just good practice. It's going to be through all, but it's going to be only that part. And click on OK, like so. And just like that, we can see that we have a good part. This is quite manufacturable. Just some few issues here and there, which I'm going to address. I've just seen it. And let's first hide this body. And you can see trouble right there. This doesn't look right. So two things or two ways we can handle this. This actually needs to be we can put a relief cut to get rid of this bend, because this is not supposed to be protruding. I think it's because we forced it to become what's it called? We forced it to become to fold on the inside. So let's first see how we can address this one. Go first to these edges and see if we can add a relief. So we can do a custom relief down here. Let's do it with that relief ratio rectangle. Use relief ratio and see how that goes first. Nothing. So I think this is another opportunity I can use to show you. Let's say, for example, you still really want this thing to remain with the same dimensions, the same form, but you need to get rid of this bend, because I can assure you this is not practical. You're not going to do this. So there's a feature right here in sheet metal that's called unfold. So we're going to select this part and we are going to just unfold. Let's just collect all bends and then unfold it. It's going to give you a semi-flat pattern like so. And these are our areas of concern. You see these ones? You don't want these ones. So we can get rid of them just using a normal sketch. So we can just sketch on that plane and it is good practice to offset it a bit. Yeah, so I'm going to take corner rectangle, say from there to there, and I think we can use our symmetry. So from here, we can have a construction line from there to there, and there, and we can mirror that about that, like so. Let's come to this other side. So we're going to take the two of these and mirror them about this other line. You can see them there. So this can be good enough, but as I said, it is a good practice to just offset it quite a bit. So we can just offset it by, say, 1 millimeters. By a millimeter, let's see how that will look like. That's too large. 1 millimeter, and then we're going to make the base geometry. What's it called? You make the base geometry, you turn it into construction geometry. So we're going to take that one. So we're going to do the same for all of this. Let's see if we can select all of them. That one, offset it. Good. And then this one, offset. Good. So we're going to go to extruded cut, and we're going to choose blind. The reason is because you can just link to thickness, and it's automatically going to trim your body according to the thickness of your sheet metal. So click on OK, like so. So you've created our own reliefs over there, and in order for us to get back to our part and see if we have actually solved our problem, we go to now fold. Remember, we did unfold, so we do fold, and then we collect all bends. Whenever you're unsure, just collect all bends, like so, and you can see now we have that relief. So this is a custom relief that you can, you can look at, and this is another way of creating that custom relief. So this is actually what you want at the corners. This space might be big, but it can be filled using anything, or you can just leave it like that, depending on the use case. But you can see this cut, it's not a very good cut, so probably we can go and address it, but for our purposes we can just leave it. So by addressing it, you can just take the distance between here and where this angle terminates and cut it. So by that you can just adjust, maybe instead of 1 millimeter offsetting it 1 millimeter, you can offset them by 2 millimeters or 1.5 until you eradicate that one. But in our case, this will still work. So with that one, we can highlight our cover back like so. Yeah, so the only thing that I can see that is not consistent here is that we have a very sharp edge over here, and how to address that, still in the sheet metal command, we're going to use a break corner. So using break corner is more like putting fillets, but it's intelligent enough to pick all the fillets on the sharp corners on that edge. Similarly to this side, you want to make them a radius into a radius, and let's say 4 millimeters. See if it's going to work. Yeah, 4 seems like it's too big. You can just put it back to 2 millimeters and see how that one looks like. I click on OK. See. So yeah, so that's that. That's really good. You can see visually it also looks quite appealing. So yeah, so this is your box. This is something very generic. If you have electronics, you can have your own cutouts here. You know, you can cut out some few things here and some few holes. You can put your Arduino or any other form of electronics. And with this one, this is quite very ready to produce. But another thing I wanted to show you guys is now you can see it's very tight, and this is not practical because practically speaking, you're going to finish this thing, let's say for example using paint or powder coating, and that's going to add a little bit of thickness. So just for good measure, I normally put some allowance between the two, around 0.5 millimeters to a millimeter. So with that one, having said that, we can see the one thing that we can change, we need some little bit of space between these two. Let me just put it in the front direction. You don't want it to hug it this tightly. You really don't want that. So to address that, we are going to isolate this one, the base, and first order of business, we're going to offset these ones a little bit on the inside, to the inside. So we're going to offset it, and the first option is to the outside. We want to change that offset to the inside, and let's make it what? Let's make it 0.5 of a millimeter, like so. Click on OK. Let's exit isolate and put it on the front view so I can see. Yes, so you want this space, you really want this space. So the other thing is that practically speaking also, you can't have like a zero gap between these two. So that is all the reason why I told you you really need this slot. You want the outer one to, at least you want some adjustability. If it's the first one, then the inner one needs to be a slot. But in our case, mostly you just want the first one to be the cover to be the slot. And just to give this one a bit much better design, the first thing we can do, first isolate, and then we can have another flange at the top. Click on there and there. Now I'm going to change the depth to 12 millimeters, just like the other one. But this one, let's see how it looks like. Oh yeah, it's going to give us the same problem that we addressed on the other one. And let's see if we can address it using another way. So let's do corner relief, and we're going to choose this part, this main part, and see if we can collect two bands. Yes, it has gotten them. So this is another way of creating the relief corners. So we're going to have them relief centered on the bend lines, and then we're going to use, say, 1.5 millimeters. This rectangle, let's just put it at ratio to thickness and click on OK. Unable to create some corners, so give it 1 ratio of 1. See, we were unable to create some coherence. So let's not dwell on that. Let's just do what we did the other time. Let's flatten. Sorry, not flatten, but unfold. Undo flatten. Let us unfold this face. Collect all bands. Click on OK. And I'm going to address these corners right there. So I'm going to use a sketch. Select on that plane. Have a rectangle. Draw up to those two vertices. Same thing here. Make sure this vertex and this point are okay. And again, we have to thank ourselves for using symmetry. Click on there. Select those two and that one. And then we mirror our design. So having done that, we still do the same thing. You just select all those, hold on Control, select that one too, and then we offset them. And this one, let's do 1.5 and see how that goes. Click on OK, and we extrude cut them. Link to thickness and OK. And boom. So we should be good. So with that one, we're going to, what's it called? We're going to go back to the sheet metal and fold it again. Collect all bands and click on OK. Like so. So there we go. We have it. Everything looks okay. This part is quite manufacturable. And you can have your enclosures right here and enclose as many things as you want. So this is just a generic way of designing parts in sheet metal, and right away you can see the reason why I chose the top-down way, because now I can look at everything in context within a part. And some people prefer to do that in assembly, but now then again you have to link those parts in very complicated ways, I feel. So yes, the part might be heavy and everything, but if you have such things that really rely on the relationship with each other, 2 parts or 3 parts or 5 parts that rely on each other, it is much better to do a multi-body design within sheet metal. The other reason is that you have a lot of control, and not that you can't get that control any other way, but let's say for instance, for whatever reason, okay, let's first of all, for whatever reason, let's say for example, we wanted to change the dimensions of this part. You can see using Instant 3D, I have all these dimensions and I can change them on a fly. So if I wanted to reduce, let's say this 100 to say 70 millimeters, and this part also 150. Remember, this is the boss. This is the original boss that we created. This one, let's say for example, we want to stretch it to 180 millimeters. And let's say for example, this 60, we want to, let's say, reduce it to 50 millimeters. For whatever reason, we can just change them over here, and then you just hit the rebuild button and everything should work, because we've used the resilient CAD modeling techniques, which is something that we're going to look at another point. You can see it has already updated because everything was done relative to something that is very stagnant, something that is not changing. So this is a very good technique of design. You can see we've changed the dimensions of the box, but our part has really held up very well. you know, we can change it to whatever we want. This is basically a parametric box, and most of the time we know that if we change anything here, everything else is going to update accordingly. So I think I've ranted for quite a while, but you get the point. So thank you for being with me. I know it's been quite a long video, but if you followed up to this point, you know, like, share, subscribe, hit the comment section, say something, say anything. If you've liked it, say I've liked it. If you haven't, say, hey, you can improve in this area. If you share different sentiments, you know, I'll be open to criticism and everything, but we can learn together. And tell a friend to tell a friend, share the good news. And I hope you've learned something in sheet metal. I've given a lot of information. Just take that which you find is important for you. So just before we close up, as I was telling you, it's not really practical to have this thing like without any allowances at the top. So just for visualization though, but it's okay as it is, you can just take this part and give it use the move copy bodies and move this part in the Z direction, translate it a little. So let's say in the Z direction, you need to translate it by the up direction rather, either 1 millimeter or 0.5. Let's just use 0.5. And this ties into the reason why we had the slots in the first place. So if we look at it from the front, you can see we have all that good clearance. And if we look at it from the side, you can see the hole. We can still access the hole to lock our things right there. You can also add additional holes over here for security and everything. But let's stop at this one, and in the second video in this series, I'm going to show you now how to take this from these two parts, because over here you can see the cut list. You have two parts. We have move copy body 1 and fold 2. We're going to give them some proper names and then now see how we can take them into proper production files. So thank you very much for joining me, and have a good one. Cheers.